Okay guys, here's Module 2 review. So we're going to start here with properties of transformations. What do they preserve? So what we need to know is that rotation, reflection, and translation preserve everything. Oops. Everything but the coordinates. Now, if you take a look at the dilation preserves angles, and it has a scale factor. Okay, what is isometry? Isometry is like dilation is not isometric. Isometry means it keeps all the measurements, means like rigid motions. What's the difference between similar and congruent? So the similar has the same scale factor. So therefore you need to use ratios, and congruent means that everything is the same. All right. So here what we're going to do is we're going to graph this triangle, and then we're going to do a dilation on it. So we will graph the original, which is going to be -15, -3, which is right here. That's S. And then -12, 15, 14, 13, 12, and -15, which is here. And then 0, -9. 1, 2, 3, 4, 5, 6, 7, 8, 0, -9, which is here. So this is my original figure. And then the next one will be when it has a scale factor of 1/3, which means you're going to divide everything by 3. So -5, -1, -4, -3. And 0, -3. So if we plot that, 1, 2, 3, 4, -5, -1, that's S prime, and then -4, 1, 2, 3 is T prime, and then 0, -3, U prime. All right, so that's how we do dilations. Next thing, if I dilate the preimage ABC by a scale factor of 2, so let's say I have A, B, and C, and I do a scale factor of 2, and let's go from the origin. So that means, remember when we did this, that you would do your lines through here and then figure out what the scale factor of 2 is. So 1, 2 would be B prime. So 1, 2 would be A prime, and 1, 2 would be C prime. So it says so we want to know, what do we know about this? So we know that all the angles are the same. All the sides have been multiplied by 2. Let's see, so corresponding angles, let's see, this side is parallel to this side. All the sides, the corresponding sides are parallel. They all have a scale factor. They all have the same scale factor. That's it. So you just want to know, like, sorry, obviously I'm doing this at school. What things do they have in common? Okay, let's move on. So congruent triangles. So we need to know, what do we need to know about congruent triangles? So if we're looking at side, 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 and I'm missing some, so that's okay. We'll just draw them in. So side, side, side. Side, side, side would be something like this, where they would have 3 sides. Side, angle, side. So a side, angle, side would be an angle between the 2 sides. The next one would be angle, angle, side. So an angle, angle, side would be an angle, the next angle, and the side that's connected to it. Angle, side, angle. So angle side angle would be an angle, a side, and then the following angle. And then finally the HL. And so if you remember with the HL, you need a right triangle, you need your hypotenuse and one of the legs, doesn't matter which one you do. Now, for similar triangles, which you want to think about when you're doing side angle side, so for similar triangles, for side angle side, think about what you're doing. You need to show, so let's just get a triangle. So let's say this is A, B, and C, and then this one is D, E, and F. So for side angle side, you would have to show that two of the sides, like A, B, and D, E, are equal to the other side. So if we were doing this, this, and this, this, and this, we would say BC over EF. And then we would have to say that angle B is congruent to the other angle, angle E. That's for side angle side. Now for angle angle, let's draw it here, A, B, C, and then D, E, F. So let's say we're doing this angle and this angle. So for angle angle, you would want to say that angle A is congruent to angle D, and angle B is congruent to angle E. So you need to show that two angles are congruent. You don't have to do any ratios for that one. Okay, find the scale factor of figure A to figure B. So the scale factor of figure A to figure B, what you're doing is saying if I'm going from A to B, which means I'm going smaller, right? So what happened when I went from angle A to angle B? So what happened is it got smaller. So 20 over 36, and 20 over 36 is the same as it has a scale factor of 5/9. Okay, determine the triangles are congruent below. This first one is angle, side, angle. The next one, they're sharing a side, so side, side, side. This next one, they're not congruent because we don't use that one. And then the next one is the HL because you have the hypotenuse and then a leg. Okay, if PQR, so P and T are corresponding, Q and S are corresponding, and R are corresponding. Find SR. So we want to set up ratios. So if we go 60 to 38, that means you want 1, 3. So 1, 3 would be 4x minus 26 over, and then 3, 2. So 3, 2 is 2x minus 1. Now, if I reduce 60 over 38, that will reduce down to 19 over 30. I'm sorry, 30 over 19. Is equal to 4x minus 26 over 2x minus 1. So we're going to cross multiply. 30 times 2x minus 1 is equal to 19 times 4x minus 26. And so 60x minus 30 is equal to 76x minus 494. If I subtract 60, I get 16x, and add 494, I get 464, and then divide by 16. So you end up with x is equal to 29, but that's not what it's asking for. It's asking for SR. So SR is 2x minus 1, so we're going to go 2 times 29 minus 1, which would give me 57. Okay, for angle, remember that you want to compare two angles. So compare, or say, actually not compare, you're going to say that the two angles are congruent. And then for the next one, you want to say that the scale factors of the sides are equal, or your ratio. Scale factors or do the ratio. And then you would want to say the two angles are equal. Okay, next page. So we did this before. It's right if your hypotenuse is equal to the sum of the squares of the sides. Here, you want, for it to be acute, you want your hypotenuse or your long side to be less than a squared plus b squared. And then here, for obtuse, you want it to be greater than a squared plus b squared. Now, don't forget this little tidbit, the sum of the two smaller sides must be greater than the third side, the largest side, otherwise it's not a triangle. So the first thing we need to do is add together. So this is 41, and that is definitely bigger than 29. So now we can do our calculation. So 29 squared is 841, and 20 squared plus 21 squared is 841. Since they're equal, it means they're right. Okay, add these two together. 14 is definitely bigger than 10. So the biggest side and then the sum of the smaller sides squared. Oops. So I've got 100, and over here I've got 106, which means that is smaller, which means it's acute. Here, 18 is equal 18, so therefore it's not a triangle. And here, 16 and 28 is 37, which is definitely bigger than 28. So we're going to say 28 squared, and then 16 squared plus 21 squared, and you get 1,444 and 697. So that's definitely smaller, therefore it is acute. Okay. SOHCAHTOA, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So here what we need to do is we need to find that other side. So to find the other side, since it's a right triangle, we're going to say this is c. So c squared is equal to 16 squared plus 30 squared. So c squared is equal to 156, square root both sides, and you end up that c is equal to 34. So now the first one, we're going to use the we're going to use q. We're using q. So that's going to be our reference angle. So if that's our reference angle, we want to do sine, we want to do this is opposite, and this one would be adjacent, and this is always the hypotenuse. So the sine would be opposite over the hypotenuse. If you reduce that down, you end up with 15 over 17. And if you remember your complementary angles, so the sine of q is equal to the cosine of r, so that means this is 15 over 17. All right, let's do the cosine. So the cosine of q would be 16 over 34. And when you reduce that down, it's 8 over 17. And therefore, the cosine of q is equal to the sine of r. So this is 8 over 17. And then for tangent, you want to do the opposite, which is 30, over the adjacent, which is 16. And that's going to give you 15 over 8. And so the tangent of r would just be the reciprocal. Okie doke. Moving right along. So here, for angle, always draw a picture. So we've got Elijah. Elijah is looking up. Here's Elijah. He is looking up at the Washington Monument. If the monument is 555 feet tall, and the angle of elevation from the point on the ground where Elijah is looking is 74 degrees, how far is he standing from the base? So we're doing the tangent of 74 is equal to the opposite over the adjacent, cross multiply, x tan of 74 is equal to 555, divide, so x is equal to 555 divided by the tangent of 74. When you plug that into your calculator, you get 159.1 feet. Okay, well, parasailing. So here we go. Now he's parasailing. Ryan spots a dolphin in the water below. If Ryan is, this is the water, 228 feet above the water, and the angle of depression to the dolphin is 15. So this is 15 degrees, which means this over here is 228 feet as well. What is the horizontal distance? And then again, we're doing tangent, so the tangent of 15 degrees is equal to 228 over x, cross multiply, x tangent of 15 degrees is equal to 228. So x is equal to 228 divided by tangent of 15 degrees. So that ends up being 850.98 feet. Okay, so now let's go through and let's solve these. So let's go to this first one of 27. So for this one, I would do the tangent of 27 is equal to 13 over x. So x tan of 27 is equal to 13. Therefore, x is equal to 13 over the tangent of 27, which makes this equal to 25.5. All right, change colors. So here I'm going to use the cosine. So the cosine of 35 is equal to x over adjacent over the hypotenuse. Cross multiply. Therefore, x is equal to 17.2. Okay, change colors. Next one is going to be sine. The sine of 46 is equal to 24 over x. Cross multiply, x sine of 46 equals 24. Divide, x equals 24 divided by the sine of 46, which means this is equal to 33.4. Okay, next color. This one we're going to use tangent. So the tangent of x is equal to 10 over 13. And remember this, when you're looking for the angle, you have to use the arc or the inverse. So tangent -1 over 10 over 13. Therefore, the angle is going to be 37.6 degrees. Okay, let's go down here and let's work on this one down here. Okay, so this one, if I solve for, let's solve for y. So that means I'm going to use the tangent of 30 is equal to 9 over y. And the tangent of 30, 0, 30, do your fingers, second finger, flip it over. So it's the square root of 1, which is 1 over the square root of 3, equals 9 over y. So y is 9 square root of 3. Okay, if I want to solve for x, I would use the sine. So the sine of 30 is equal to 9 over x. So x, oops, sorry. So let's figure out what the sine of 30 is. 0, 30. Sine is on the bottom, which is going to be the square root of 1 over 2. And then just cross multiply, so it equals 18. All right, let's go to the next one. So I just need to, now this is a 45, 45, 90, which means I only have to solve one side because x and y are equal. So let's do cosine. Cosine of 45 is equal to the adjacent over the hypotenuse. And the cosine of 45 is the square root of 2 over 2 equals y over 19 square root of 2. So I've got 2y is equal to 19 times 2. Square root of 2 times the square root of 2 is 2. So 2y is equal to 38, which means y is equal to 19. Okay, let's take a look at these two problems. Now, these are the ones where it would probably be easier if you just took them apart. So if I want to find x, I'm going to first take a look at this triangle right here. So if I'm going to find x, that means I'm going to do the sine of 60 is going to be equal to opposite 27 over x. And the sine of 60, 0, 30, 45, 60 is the square root of 3 over 2 is equal to 27 over x. So the square root of 3x equals 54. So x equals 54 over the square root of 3. Multiply by the square root of 3. 54 square root of 3 all over 3. And 3 goes into 54. Let's see, 18 times, so 18 square root of 3. Okay, so now what we need is we need another side. So we've got that this is 18 square root of 3, but when you take a look at this other triangle, this triangle right here, you have no sides. So we want to find this side so that we can use it for that triangle. So if we use that, if we find that side, that would be the cosine of 60. So the cosine of 60 would be equal to whatever that is. Let's just call it u. Okay, so that would be u. Oops, sorry, not cosine, that would be tangent. My bag. Okay, tangent of 60, because I want to use, that would be opposite, and opposite is 27, adjacent is u. So we've got u, wait, the tangent of 60, 0, 30, 45, 60, flip it over, it would be the square root of 3. So square root of 3 is equal to 27u. So we've got the square root of 3u is equal to 27. And then if we divide by the square root of 3 and multiply, we get 9 square root of 3. So this one right here is 9 square root of 3. Okay, so now I'm going to use that. So let me go ahead and make myself some room. So let me erase this so I can get some room. Okay, so if this is 60, this angle right here is 30. So to find z, I can do the tangent of 30 is going to be equal to z over 9 square root of 3. And the tangent of 30 is 1 over the square root of 3. So z and 9 square root of 3. So I got 9 square root of 3 is equal to square root of 3z. When you divide by the square root of 3, we got z is 9. If we want to find y, what we can do is we can use the cosine of 30, which would be 9 square root of 3 over y. And the cosine of 30 is the square root of 3 over 2, which is equal to 9 square root of 3 over y. So square root of 3y is equal to 18 square root of 3. When you divide by the square root of 3, it gives you 18. All right, let's go to the next one. So the next one, we will start off by, let's see, this triangle right here is the only one that has a side. So let's find x first, which would be tangent. So the tangent of 60 is equal to 6 square root of 3 over x. Tangent of 60, 0, 30, 45, 60 is going to be the top, which is the square root of 3 over 1 equals 6 square root of 3 over x. So the square root of 3x cross multiplying is equal to 6 square root of 3. So x is equal to 6. Okay, so now we need to, again, for this triangle right here, we don't have a side. So we want to find this side right here. If we do from the other, that means we would use sine. So the sine of 60 would be equal to 6 square root of 3 over u. And the sine of 60 is the square root of 3 over 2 is equal to 6 square root of 3 over u. Cross multiply, square root of 3u is equal to 12 square root of 3. Therefore, your u is going to be 12. So we're going to replace this with 12. And now I can look at that triangle, so I know that y is equal to 12 as well, because that's a 45, 45, 90. Now, if I want to do the other one, I just need to find z. So I can use the cosine of 45 is equal to the adjacent over z. Cosine of 45 is the square root of 2, over 2, which is going to be 12 over z. So the square root of 2z is equal to 24. So we got z equals 24 over the square root of 2, bad manners. So now we've got z is equal to 24 square root of 2 over 2, which makes it 12 square root of 2. Okay, that's it. That's your review. Good luck, guys.